Okay, let's do some practice problems. So number one, a 15 kilogram box is being dragged over a concrete floor with an applied horizontal force of 40 newtons. If the coefficient of kinetic friction is 0.25, what is the acceleration of the box? So it's going to help with all of these to draw a free body diagram. So I'm going to draw my dot. FG is going to be going down. Fn is going to be equal but going up. I've got a force of friction going backwards. And I've got a applied force of 40 newtons. And they said it's being dragged, so I'm going to assume that the applied force, Fa, is going to be longer, right? Okay, so that's my starting point there. Really, what we got to do, like when it's asking here, what is the acceleration of this box? So what I'm after here is I got to figure out the force of friction. And then once I figure out that force of friction, I'm just going to be able to go 40 minus that to figure out what my net force is. And then I'm going to be able to go F is equal to ma, or F net is equal to ma, and then solve for acceleration. That's kind of where we're at here. Okay, so in order to figure out the force of friction, though, I need the normal force, because force of friction is equal to mu times the normal force. And the normal force, though, I can figure out. Fn is going to be equal to Fg, which is equal to mass times acceleration. In this case, that's gravity. So that's going to be 15 kilograms times 9.81 meters per second squared. So Fn is going to be equal to 147.15 newtons. Okay, so now that I know that, the force of friction is going to be just mu times that. So mu times Fn, which is equal to 0.25 times 147.15 newtons. So the force of friction is equal to 36.79 newtons. Okay, so now that I know that, right, that's step number one, that's this. That is 36.79 newtons. So if I want to figure out the net force here now, F net is equal to, it's going to be equal to Fa plus force of friction. So Fa is 40 newtons, and I'm going to add negative 36.79 newtons. Well, that should be a 9. Pretend that's a 9. So that's going to be 3.213 newtons. Okay, so that's the force responsible for this acceleration that it wants us to find, right? That's the net force. So now the last thing we got to do is just say acceleration is equal to F net over mass. So that's going to be 3.213 newtons divided by, our mass was 15 kilograms. So the acceleration is 0.21 meters per second squared. All right. Number two, a 20 kilogram apple crate is being dragged across the floor at constant velocity with a horizontal force of 25 newtons. What's the coefficient of friction? So let's draw our free body diagram. You've got Fn, you got Fg, we've got our force applied, and we've got our force of friction. And constant velocity, they're all going to be the equal length, right? There's no net force involved here. All right, so I know my applied force, that was equal to 25 newtons. And now the way, maybe you can see like a pattern kind of starting here. The way these are like going to work for the most part is that you figure out Fg, which is Fn, and then use that to find force of friction. So it's kind of like a pattern like this, if that makes sense. So it goes force of gravity, normal force, force of friction, and then you use that with your applied force. That's kind of the general trend of these things. So the force of gravity, we know the mass, so really we just need to multiply that by 9.81. So Fg is equal to mg. So that's 20 kilograms times 9.81. Capital F, G is equal to 196.2 newtons. And I could say, therefore, the normal force is going to be equal to 196.2 newtons. And you might be asking yourself, why didn't I put like a negative symbol in there for 9.81? I could have. It would have given me a negative answer, right? But what I've just been kind of doing instead is talking about the magnitude of these things. So without putting a little arrow over top, I'm kind of just talking about just the magnitude. So I said that the magnitude is 196.2, and I know that's down. So the normal force is going to be 196.2, and I know that that's up. All right, so let's use that. And now part 2, our new formula here. Force of friction is equal to mu times Fn. So the force of friction is going to be equal to, now we need to rearrange this to say mu, or the coefficient of friction. I just don't like saying coefficient of friction all the time. Mu is equal to the force of friction over Fn. And you might be saying, yeah, but Mr. Brown, we don't know what force of friction is. But yeah, we do. We do know what the force of friction is. The force of friction, because this thing is moving at a constant velocity, is 25 newtons as well, right? So, and technically these are absolute values, right? So it doesn't matter that this is a negative force of friction. So mu is just going to be equal to 25 newtons divided by 196.2 newtons. And we get 0.13, and there's no units, right? Okay, number 3. It says a rope is attached to a 50 kilogram box. Is being pulled at an angle of 25 degrees across the horizontal floor, where the coefficient of static friction is 0.2. What is the acceleration of the box if a 200 Newton force is applied? So here's my free body diagram. I have Fg going down. Notice that Fn isn't the same length as Fg this time. And the reason for that is because I'm going to split this vector into its components, right? Into its x and its y components. Fg would be equal to this vector plus this vector, right? Hopefully that makes sense. So what we need to do, what we're going to do, well, okay, I'll walk you through the process here. So we want to figure out what Fn is, because we can use Fn to figure out what the force of friction is. Once we know what the force of friction is, we're going to take that and the x component of this thing, of this triangle, to figure out what our net force is. Because the net force in the x direction is what we care about, because it's accelerating in the x direction. So once we know the net force, then we can find our acceleration pretty easily, because force is equal to mass times acceleration. So that's kind of the general trend of where we're going here. Okay, so what we got to do is break this triangle into its components. So let's do that first. So the bottom here, so F applied in the x direction is going to be equal to 200 newtons times cosine 25 degrees. So x applied in the x direction is going to be 181.262 newtons. All right, in the y direction, it's going to be force applied in the y. Same thing, but sine 25. Should say y. And that's going to be 84.524 newtons. And I'm just leaving my numbers long, right? Because I'm going to just leave them long up until the end. All right, so I know those things now. So let's figure out Fn. That's our first one we want to do. So Fn, we got to make a little formula to this first. So Fg, like I was saying, and the magnitudes here, I'm saying like the magnitude of Fg is going to be equal to the magnitude of Fn plus the magnitude of Fa in the y direction. Right? These Fa in the y direction, Fn, they have to add up to Fg to make this thing balanced, right? It's not accelerating, so they're equal to each other. So if we fill these in here, whoops, I thought I was recording, but I wasn't recording. Sorry, guys. Okay, I don't really know where I made a mistake here. Hopefully it wasn't too bad a spot. So what I've done here is I've got Fg up at the top, and that's going to be equal to Fn plus Fa in the y direction. So that's going to be this part over here, right? So 84.524 newtons. And they have to be equal because this thing isn't accelerating up, it's not accelerating down. Okay, so and if you plug that all in and solve for Fn here, Fn is going to be equal to, so that's going to be equal to 405.976 newtons. All right, so we got Fn. Now what we got to do is figure out what force of friction is. So the force of friction, oh, it should be a capital F. Force of friction is going to be equal to mu, and these are absolutes, mu times 405 point, I'll say Fn first, times Fn, which is equal to 0.2 was our coefficient of friction, times 405.976 newtons. So force of friction is going to be 81.195 newtons. Okay, we're almost there. So I got that. Now, what we got to do is figure out what the net force is between those. So the net force net is going to be equal to this, right, in the x direction. So 181.262 newtons. And I'm going to subtract the force of friction, right, because I want to figure out what the net force is between those. So I'm going to subtract 81.195 newtons. So the net force is 100.067 newtons. Okay, we're almost there, I promise. So now last thing, we're going to go acceleration is equal to F net over your mass. So 100.067 newtons divided by 50 kilograms. Our acceleration is going to be equal to, I get 2.0 meters per second. So one of us was off a little bit. Mr. Light, who made this key, or myself. I'm not sure. With sig digs, I think I kept track of all my sig digs really well. So I think the mistake's on his end, but I apologize to him if it's on my end. Yeah. So that's your answer there. Okay, so I want you guys to go ahead and do the handed assignment. Make sure that you draw your free body diagrams for all these. I'll make sure that you guys definitely have free body diagrams to start with. It does help for solving these problems. Okay, so there's only 9 questions, but you can see that some of these take a while. So I would get at it now.